Assalamualaikum warahmatullahi wabarakatuh and very good day to my panelists. Welcome to my final project presentation. Let me introduce myself. I'm Mohd Zuhakimie bin Zulkefli from Faculty of Mechanical Engineering. I will present the final project and its title is Titanium Powder Analysis in Additive Manufacturing under the supervision of Associated Professor T.S. Dr. Noor Hafiz bin Muhammad Noor. Project Summary. This project proposal consists of several main subtopics which discussing about simulation of additive manufacturing AM process for titanium TI6A for VVLS Dyna. Its main purpose is to give multiple result output and provide future prediction for the material behavior of the material after go through AM process. Selective laser melting SLM will be developed by LS Dyna and collapse behavior of the microstructure will be studied in this process. Several objectives have been identified that have been set as key milestones for the entire project achievement. Several publications and reports from LS study have been used as guidance through the entire work project. Each document and article collected is relevant to the project title and provides key formulas and parameters, particularly material composition for titanium. Previous researchers also create guidance for using LS Dyna software because they managed to mimic the same process method that is being used in the project. Introduction. Because of their outstanding properties combining lightweight and energy absorption, cellular materials have been interesting in many fields such as aerospace, traffic, military technology, and biomedical engineering. One of the AM processes was chosen for this project research, which is used to study on collapse behavior of printed-graded titanium macrolithic structures. Titanium is one of the most widely used metals in many industries. However, because of the microstructure alteration and allotropic transformation that occur during thermochemical processing, the AM method was designed for selective laser melting materials. It's been said, after SLM manufacturing, stress relief, if requirement utility is fulfilled, would be advantageous. The surface finish of this process demonstrates that SLM process parameters play a role in influencing behavior of the product. As a result, this operation will be carried out and the result will be displayed using D3 part which was developed using LS Dyna software. Literature review. 4 important points will be provided from the collection of reading that has been made from the results of various readings. For the first, aspect of surface roughness titanium 6A from the first journal from YCs and all found about problem with the AM process is that the surface roughness of the parts that are made is very high. Different scan speeds, powder, and layer height should be responsible for the different surface roughness. Zuhakimie have been said that SLM process will produce surface roughness around 5 to 40 micrometer. From the surface finish of this process, it shows the parameter of SLM process play a role in changing behavior of this product. After that, Gange and others state that microstructure of SLM titanium 6A is reported to be composed of 4 distinct materials: primary, secondary, tertiary, and quartic metals. Porosity that occurs in 3D laser printing process, LIPI have been right. The uncontrolled pores in the AM fabricated titanium will degrade its characteristic. Gas pores and lack of fusion pores are the common type of pores found in additive manufacturing products. Lastly, SLM on the other hand primarily relies on heat dissipation where conduction with the unmelted particles surrounding of the component. The titanium molten pool created by SLM, for example, has a maximum temperature of around 2710 K and a cooling rate around 104 to 106 kilobytes per second. This fact has been right by Gu Koldus. Problem statement. The surface roughness of SLM built-in titanium parts result conclude that different parameters provide different surface roughness. These AM process have intrinsic limitations including the risk of porosity. The uncontrolled pores in AM fabricated titanium will deteriorate the material properties. Uncontrolled porosity is actually very common in the AM parts, such as gas pores and lacks of fusion pores. When exposed to the loading, particularly under the unaxial tensile load parallel to the building direction. The sharp tips of these parts are prone to concentrate local stress, leading to premature failure. Hence, an extensive focus has been taken to produce better quality materials by AM process on the titanium by simulation. Objective. This final year project consists of several objectives which need to be focused on for an entire project. First, to develop 2D simulation of printed process of AM process by generating the D3 plot data on project model. Then, to observe mechanical behavior of the particle material in wide range of temperatures caused by heating and phase change for prediction of residual stress. And lastly, to validate mechanical model after being simulated by additive manufacturing process, selective laser melting. Scope and limitation. The simulation will be done using LS Dana software by generate D3 plot, which consists multiple steps and procedure. The material composition and material properties will be measured and its units to be identified first to make sure there is no error during the simulation progress. After several parameters and boundary conditions have been assigned on the system, it will generate multiple results, which giving full visualization for the outcome of the design system. The LS Dana system will determine whether the parameter of boundary condition look suitable on each other. And the wrong input will be shown at the end of the result and the user need to terminate or submit the job which have been assigned. Let's move to the methodology. Methodology that were used in the LS Dana will be divided by the 4 phases, which is geometry setup, define materials, define output, and the run of the data. This part will be summarized all of this flow of the project to make a smooth flow on simulating the SLM process and successfully study on the material behavior of the titanium. Methodology for this project are using 4 phases, which is simulation, investigation, validation, and documentation. The simulation on the phase 1 will conduct by objective 1 and objective 2. Aim is to the objective 1. Objective 1 needs to identify the steps to simulate the process on LS Dana and then develop 2D simulation of AM process. Follow up with the objective 2, which is observe mechanical behavior of the particle material. For the phase 2, this phase will conduct the investigation the macroelectric structures by using string stress graph and find the suitable parameters of titanium for SLM process. Continue to the third phase, which is to achieve objective 3 goals. In this phase, where validation of the mechanical model will run after being simulated by AM processes. For the final phase, which is to complete the final documentation and report writing, that data which is taken by result from the simulation using LS Dana from objective 1 and objective 2. Preliminary or expected result. During the development of SLM simulation analysis, same approach which have been used by previous researchers in terms of methodology and step of assembly will be used. Particles of the metal powder can be of different size and the model must contain suitable number of particles to obtain statistically significant solution. Those several parameters which is being used, such as for titanium, use is titanium anneal 700 to 785 degrees Celsius with density of 4.43. Its Poisson ratio is 0.342. Ultimate and yield tensile strength is 950 MPa and 880 MPa. Shear modulus is 44 GPa. Modulus of elasticity 113.8 GPa and shear strength is 550 MPa. The cubic lattice sample had the dimension 30 x 30 x 30 mm consisting of 6 BCC unit cells. Selective laser melting parameters will be applied with the different parameters, which is different rate laser power and scanning speed. There will be 4 different levels will be applied, which is laser power 120 watt at the level 1, followed by 200 and 275 and 360 for the last level. For the scanning speed will be start by 25 on level 1, followed by 510 and level 2 760, and for the final level is 900 mm/s. By using the parameter that were stated, stress strain curve as an experiment result will be provided. Result of finite element analysis collects pattern of the uniform lattice structure at different constraints. Different strains also being provided at the final process of the simulation. By using all of the data From the final phase simulation, the documentation of this project will be generated based on the data collected before. Feature study. The titanium alloy properties will be used to the workpiece when doing a SLM process. Several new results such as amount of temperature rate will be analyzed by assigned through the element type of mesh for workpiece. As stated before, different scan speed, powder size, and layer height should be responsible for the result. Height of split thermal temperature and different kind of parameters will cause the microstructure be in different phase. The result for this measurement for this type of AM process will be developed and will be shown as before. Different laser power and scanning speed also will be assigned for the simulation to produce different output result for further study of material behavior. Gantt chart. For the Gantt chart, we'll be showing you about the planning of FYP1 and FYP2. For the purple one, which is planning, and the blue one, which is actual work have been done. Thank you for the time. If you have any inquiries about this FYP1, you can contact me from the information above. Thank you.